With this one, guys, population of bats in a large cave is 130, growing exponentially at 20% per year. Right function represents the population of bats after 10 years, where the monthly rate of change can be found from a constant in the function. Okay, so this comes from 2.2b. So basically, remember when we did the doubling and the half-lives? It's very similar to that process. So you guys did identify that it was a growth and that you set up the problem correctly. So most of you got this part. All right? Which that's half the battle. That's the first step. So you at least got the very first step. So if I simplify that a little bit, all right, I get that. Now, we're going to write a function to represent a population of bats after 10 years and the monthly rate. So we got to convert the units here. So T represents the number of years. All right, I want to know what the monthly is. So basically, in 1 month, what the rate grow to. Okay, so how many months are in a year? 12. So there's 12 months in 1 year. Now, if this is what it is for 1 whole year, and I want to know for a singular month, all right, let's say month is M. So M is equal to a month. How would I write that? So I want to know what it is after 1 month. So in other words, if I want to know how much of the year that is, how would I figure that out? So, guys, if I want to know how much of the year 6 months is, how would I figure that out? How much of the year is 6 months? Half. So in other words, 6 over 12, right? So if I wanted to find the rate for 1 month, and this is the rate for 1 year, wouldn't I just raise it to the 1 over 12 power? All right, so that's the first part that you got to do. So A is 130 times 1.20 raised to the 1 over 12 power. Now, that's part of it. The next part of it is it wants us to write it in terms of T, but in months. T represents years, but we want it in months. So let's say that they told me 2 years. How many months is that? 24. How'd you figure that out? 2 times 12, right? What about 3 years? 36. So this part right here, if this represents 1 year or in years. So this part represents the in years part. Our new exponent has to represent the number of months. So we would say 12t. All right. So if you need to find the rate inside, you would raise it to however you would converge between the two. So for example, since we're converting from a year to a month, if we went for 1 month, and they originally gave us a year. Well, 1 month is 1/12 of the year. Okay? So they asked us to give us the rate for 2 months. We would use 2/12. Does that make sense? But then our timing has to be in terms of months. So it's originally years. We go to find the total number of months in a total set of years. We multiply it by 12. So we're first going to raise 1.20 to the 1/12 power. So someone their calculator put that in for me, and I want 4 decimal places. So raise 1.20 to the 1/12 power. It's 1 point what?
131.9902.
Alright, so it's 1.0153. So 1.0153 raised to the 12th power. So this is our new function. Okay? This is the rate after 1 month. This is the rate for a year. Alright? If we write it in terms of t. So we want the rate per month, but if t is the number of years and they want us it in terms of t, that's why we have to multiply t by 12. Because technically that rate is for 1 month. So I would write 130 So I would type in 130 times 1.0153, and I would raise it to the 12t power. So what's my percent of increase per month? We talked about this yesterday. Remember, your growth factor is right here in the parentheses. So that is how much total you have. You now have 101.53% total now after 1 month, all right, of your original population. So remember, this is 1 plus R. So I want my rate of increase, which is just the R. How would I find that? You would just subtract what? 1. So if we subtract 1, this will be 0.0153, which, what's that as a percent? 1.53%. All right. So that's our rate of growth for 1 month. So guys, this one's a particularly hard one, but that's why we did it together as a class. It's your single problem on your Delta Math, your 2.2 Delta Math. I can assure you on your tests, it won't be this difficult. They'll be similar to what we did yesterday, where the time you'll write in terms of that. Okay? But you still need to know at least the basics of how to do this. Now, I'm going to take a picture of it, and then I'll post that as part of your notes for today. So if you didn't get it written down, I'll post it in Canvas. And guys, 2.2b is probably the most painful part of exponential functions for the sheer fact that it gets confusing. All right. And if you submit it, the correct answer. So this is the only singular problem on that 2.2 delta math. So I did it as a warm-up because I want to go over it. Okay. All right, I go to erase this. All right. So today we are finally breaking away from word problem land. Whoopee. But now we're getting into solving exponential equations by hand. All right. So the first way you do it that we're learning today is actually really easy. So what I want you guys to do is first off take out your packet and turn to page 13. But I also want you to take out that blue power chart that we filled out on Friday of last week. So that blue power chart. So remember the one that had like the table and it had all the numbers? Take that out. It'll be very helpful. Page 13, take out your blue power chart. And then if you have your Chromebook out, if you could just clamshell it for me. So, guys, this lesson is relatively short today. All right. I told you it's not going to be as long as yesterday. So you'll have some work time today. So, now, could you solve these with technology? Yes. But this particular method is very easy. And not like easy and like, oh, I think it's easy. Yeah, so it's easy. No, it's literally like if you can tell like that 2 raised to a certain power is this and 2 raised to a certain power is that, it's straightforward. Let's put it that way. It's not a whole lot of steps. Okay. So these you should be able to do by hand. So with solving exponentials, there are 2 ways to do it if you're doing it by hand. There is doing it with this common base method, which is what we're learning today. And then there is the logarithm method. So that happens when you don't have common bases. All right. And we're not learning that today. We're learning that in like 2 days. Okay. So we'll learn that Friday. Now, because that one involves logarithms, which we're not going to learn until tomorrow what those are. Okay. Now, the common base method is essentially what it sounds like. You're finding a common base with that number. Okay? So, let's just look at letter A on example 1. So remember, we can solve these by finding a common base. And remember, the base is essentially the number that's connected to the exponent. All right, so the big number that the exponent's connected to, that's your base. And so we want to ask ourselves, if our base is 2 here, what base, and so you can look at your power chart, would give you a value of 16? So 4 would be 1, but I want it to match this base of 2. So in other words, does 2, is there a base, a power of 2, that will give us 16? So that's where you look at your power chart. So if I look at my power chart, guys, this is how you're looking at it. I'm looking for base 2, and I'm trying to find a number, see if 16 pops up in it. And it does. So that's an exponent of 4. So what we do is that we're going to rewrite this. We're going to rewrite 16 in terms of that common base. So this will now be 2x is equal to 2 to the 4th power. So all we did was convert 16 back to its exponential form so that the bases are exactly the same. And this is why I want common bases. This is why the common base method is very, very nice. Because once we have common bases, we can essentially say bye-bye to those bases and bring down what's left in our exponents. X equals 4. That's our answer. So that's why your power chart, that's why I made you guys fill that out, because it will help you find common bases easily with at least the problems that we're going to do. You can also use your calculator and just do some guess and checks, because some of them you can kind of eyeball and be like, okay, one of them has a base of 3, so I'm probably looking for a base of 3. All right. Let's try B. So 3x is equal to 27. So since one of ours is a base of 3, and that's a pretty low number, check to see if there's a 3 raised to some power that gives us 27. So 3 raised to the third power. So I would have 3x is equal to 3 to the third power. So again, we're rewriting that number in terms of its base and exponent. So as a number raised to some power. So now that our bases are the same, I could say bye-bye to them. Bring down what's in the exponent, x equals 3. Now, what about this one? So 5x equals 1 over 25. So think about this carefully. This is where your power chart definitely comes handy. Right. So I'm probably looking for a base of 5. So 5 raised to the negative 2 is 1 over 25. So bases are the same, so I can cross them out. Bring down what's in the exponent. X equals negative 2. All right. Now this last one. There's 2 different ways you can do this. You can either rewrite 16 in terms of a base of 4, or you can rewrite 4 in terms of a base of 16. There's a way to do both. Okay, do it by 4. So how would I rewrite 16 in terms of 4? So if I want bases of 4, so 4 squared would be 16, but we still have that x, so we're going to put on the outside. Now, what's the unspoken exponent for 4 if it's just by itself, if we want a base of 4? 1. Now, through the power rule, I can multiply that x to the 2. So this becomes 4 to the 2x is equal to 4 to the first. I have the common basis, so this is now 2x is equal to 1. So how do I solve for x? Divide both sides by 2. X is equal to 1/2. The other way you could have done it and got the exact same answer is if you did in terms of 16. 16 is actually the one that will give you less steps. Because what's the square root of 16? 4. We can write a square root as a fraction. What fraction do you think that is? So we can write a square root using a fractional exponent. So the exponent will be a fraction. What fraction do you think that is? It's on your notes. That look familiar? So remember, if you have the square root of 16, there's an unspoken 2 here, unspoken 1 here. You take whatever's in the exponent next to the base, and you take whatever the root type is, 1 over 2. So same bases, we can cross them out, bring it down. We still get x is equal to 1/2. Now, guys, if for all else fails, if you just forget how to do this, obviously, if you just put both sides into Desmos, find the point of intersection, whatever the x value is at that point, that's your answer. So if you ever want to guess and check yourself, you can always, not this one. Crap. So if you ever want to check yourself to make sure that you did it correctly, you can always in Desmos type in both parts. So 16x and then 4. I have to actually put y equals. Find the point of intersection. What's the x value at that point? 1/2 or 0.5. That's exactly what we got, right? So, guys, anytime you ever see an equation, especially in this class, and you don't remember how to solve it by hand, do it in Desmos. You're not going to hurt my feelings, especially if it's on your test. Okay? I'm more concerned with, can you actually figure out a strategy to help you solve it than if it's my particular strategy. Okay? Because, there's more than one way to skin a duck. If you're a hunter, you would know what that means, but it's a saying. All right. Now, exercise 2 talks about specifically the power rule, which basically says that if you do a more challenging changing of the bases, we have to manipulate the right-hand side of the equation so that it shares a common base with the left-hand side. Now, in order to do this, sometimes we have to manipulate both sides so they have a common base. So the ones we did previously, only one side, we had to change the base. Now we're going to look at when we have to change the base to both sides. All right. So before we do that, we have to review an exponential law, which this is the power law or the power rule. All right. So this exponential rule that we're talking about is the power rule. And all it states is that if you have x raised to the y power and it's all raised to the z power, that's the same thing as x raised to the y times z. You just distribute the x. You just distribute the z to the y, multiply them together. That's all you got to do. That's all the power rule states. So for this one, we have distribute here. So my new expression would be what if I distribute that x to the 3? 2 raised to the 3x power. That's it. What about for letter B? If I distribute the 4x to the power of the 2, what's the new expression? 3 raised to the what? 8x. 2 times 4 is 8. Now, a little bit more here because we actually have an expression. So, what we're going to do when we multiply them together first is we're actually going to write out 5 times -1 and then in parentheses 3x minus 7. So then to simplify what's in the exponent, what do I have to do now? Distribute the -1. So this is now 5 raised to the -3x plus 7. All right. So don't get thrown off if you have like an actual like 2-term expression in here. You just write it out like a distribution problem and then you just distribute it. Okay. And then same thing here. Even though it has an x squared, it's still just a distribution problem. So this would be 4 raised to the negative 3 times 1 minus x squared. You would distribute the negative 3. 4 to the negative 3 plus 3x squared. Any questions on the power rule? Now, the reason I'm bringing this up is that sometimes when we change the bases, there's already something in the exponent, like the variable. So whatever we change the base to and raise it to that specific exponent. So for example, if we changed it to base of 2 and our original number was 16, 2 to the 4th power, but let's say that 16 also had an x connected to it. We'd have to use the power rule to distribute the 4 to the x, so we get 2 to the 4x power. Now, that probably doesn't make any sense because some of you guys are definitely visual learners, which that's fine. I'm a visual learner too. So let's look at letter A. Now, both of these two bases share a common base. So look at your power chart and see which row that both 8 and 32 end up in. Not the row, column. Look at the column and see which column 8 and 32 both end up in. And then that column will be your base. 2. All right. So we're going to write this in terms of a base of 2. Now, 2 to the what power is 8? 3. So I got 2 cubed, and then I'm going to write the x on the outside of the parentheses because it still exists. What about 32? 2 to the what power is 32? 5. All right. Now, before I can cancel out the bases, I have to invoke the power rule for the left side. So I'm going to multiply the 3 to the x. Right. So this will be 2 raised to the 3x is equal to 2 to the 5th. Now I can cancel out my bases and bring down what's left in my exponent. So this will be 3x is equal to 5. So what's the only thing I got to do to solve for x? Divide both sides by 3. So x is equal to 5/3. Now, guys, what's a way that you can check yourself besides just the Desmos method that I showed you? Plug it back in. So let's say in my calculator, I'm going to plug the 5/3 back in for x. So in my calculator, I'm going to do 8 raised to the 5/3 power. And I should get 32, which I did. All right. So that's a way you can check yourself with your answer. Also, if it was a multiple choice problem, you could always just plug in whatever your multiple choice answers are for x if you forgot how to do it. See if one side equals the other. Test taking strategies. Guess and check. All right. Okay, let's look at letter B. So same thing, we got to change both bases on both sides. So look at your power chart again. What column? Right. So 9 and 27 share a base of 3. So if you look at your power chart, the column where both 9 and 27 end up in is the one that has the base of 3. So we're going to write these both in terms of 3. Now, for the 9, I'm going to rewrite, I'm going to put parentheses around it, just leave a little bit of space for the exponent, and I'm going to put 2x plus 1 on the outside, because I know I'm going to have to invoke the power rule at some point. So 9 is the equivalent of 3 raised to the what power? Second power. 27 is the same thing as 3 raised to what power, not this group? 3. So 3 cubed. So now we got the common bases, but we just need to do the power rule first. So I'm going to rewrite this as 3 times 2 raised to 2x plus 1 is equal to 3 cubed. Now, you can either go ahead and distribute the 2 to the 2x plus 1, or you can cancel out the bases, bring it down, then distribute. It doesn't matter which way you do it. So I want to distribute first here because I like all my chickens in a row. So this will be 2 times 2x is 4x plus 2 is equal to 3 cubed. Same basis, so I can cancel them. This is now 4x plus 2 is equal to 3. So now, we start with an exponential equation, but now we have a nice linear two-step equation that you guys have been learning how to solve since Math 1, 8th grade. All right? So that's my first step for solving for x. Subtract the 2. So this group right here, not another word today. I want to hear from the rest of y'all because they're carrying you. What's my last step? You would do what? Divide by 4. So this would be x is equal to 1/4. All right, any questions on letter B? All right. Try letter C on your own. So both 125 and 1/25 end up on your power chart under the same column. Figure out which column that is, convert the bases. Uh-huh. Yeah, go ahead. So my little sleepy babies, put your heads up. Come on. So if you have your power chart filled out, that's what I said, you might want to take it out. Look, there's a column for both 125 and 1/25. So 125 is the same as 5. All right, guys. So check your answers. So I kind of skipped a couple of steps, but 5 cubed is how you would have wrote 125. So if I didn't skip the step, you would have seen it like this. 5 to the -2 is 1 over 25. So 5 to the -2, parentheses, 4 minus x. Then I have both the power rule, so I distributed or multiply the two powers together. So I got 5 to the 3x, 5 times -2 times -4x. So I then canceled the bases and brought down within my parentheses. Then distributed on the right side, so I got 3x equal to -8 plus 2x. Subtracted the 2x to the other side, you just get x equals -8. So any questions on this? And again, guys, yes, you should know how to do it by hand, but if all else fails, put it in Desmos, find the point of intersection. Put both sides of the equal sign separately into Desmos, make 2 separate graphs, find the point of intersection. That's how you can solve any equation I ever throw at you. Yeah, any. Hold on, I'm looking at something. Yeah. Yes, sir. Say that one more time. That. Is that what you're asking? I subtracted the 2x on both sides to get the variable on one side, and 3x minus 2x is just x. I didn't really have to do anything further. Any other questions on this one? All right, one more, then we're going to take our 5-minute break, and that'll give you work time for the rest of class. All right. Oh, wow. All right, so this last one. We got a quadratic in our exponents, so we're probably going to have to solve it like a quadratic. So first off, I'm probably going to have to write it in terms of a base of 2. 2 raised to what power can give us 64? 6. So 2 raised to the 6th power can give us 64. So I'm going to rewrite this as 2 to the x squared minus 3 is equal to 2 raised to the 6. 2 to the 6th power, 64. So 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. Yeah. You're basically doubling every time. Now, got the same base, canceling them out. So I get x squared minus 3 is equal to 6. Now, this is review from last year. When you solve a quadratic function, the first thing you got to do is get one side equal to what? 0. Good. So I'm going to move the 6 over to the other side. So I'm going to subtract it. So this will be x squared minus 9 is equal to 0. Now, we can easily solve this one by factoring because x squared minus 9 is what type of polynomial? I'll give you a hint. DOS. What's the acronym DOS stand for? You learned it last year. So what does the acronym DOS stand for? Because that's what this is. I'll give you another hint. The first word's difference. Difference of square. There you go. So it's a difference of squares. All right. And all that means is that if you have a squared minus b squared, you can factor it as a plus b times a minus b. So you just take you take the square roots of both terms, separate one by a plus, one by a minus. Easy peasy lemon squeezy. So x plus minus. Because we know the square root of x squared is x. What's the square root of 9? 3. Both equal to 0. Then our last step for solving is to separate both factors into little mini equations. So I have x plus 3 equals 0. X minus 3 is equal to 0. So I would get x is equal to negative 3. X is equal to 3. And those are my two answers. So our answer over here would be plus or minus 3. Because remember, the symbol plus or minus is just the way to shorthand positive 3, negative 3. Now, if you didn't remember how to solve a quadratic by hand, all you had to do was just put both of these sides into Desmos and then find the point of intersection. All right. So guys, when in doubt, like if you ever forget how to do it by hand, which that's okay because your EOC is all calculator active, put it in Desmos. All right, Desmos is your friend, and trust me, Desmos will be your best friend on that EOC. And I will teach you how to make it your best friend. I'm going to teach you guys how to make Desmos your, I'm not going to say the rest of it. Fill in the blank. Desmos will be your female dog by the.
Oh,
I'm not
say it.
So I'm going to make sure that you guys know how to use Desmos effectively for this EOC. So start practicing it now because then it'll make your life easier when you get down to the end of the semester. All right. So I'm going to go ahead and give you guys your break. Be back in this room by 10:25. When you come back, you're working on any type of classwork for the rest of class.